Hi everyone, I wanted to pick a problem where I talk about all the different methods of graphing a line. So I'm going to use a really basic equation here. Let's just use 5x plus 3y is equal to 15. Okay, so let's list all the possible ways that we could graph this thing. So in 1.2, we learned that we can choose any value for x. And then we can solve for y, right? And then we can graph the line from there. And again, all you need is 2 points to graph the line. So let's look at doing this. So let's say that I have x and y, okay? So let's put in, let's put 1 in for x. So I have 5 times 1 plus 3y equals 15. All right, this is going to take a little bit of work. So we have 5 plus 3y equals 15. Subtract 5 from both sides. And then we get 3y equals 10. Divide by 3. And we have y is equal to 10/3, which probably makes us sad, right? Because ideally, when we graph these lines, we really want to land on these sort of perfect, right? We want whole numbers, we want integers. They can be positive, negative, or 0, but we really don't want fractions. Okay, so the reason I'm going through this in this method is to help you understand how best to choose a method. Okay, so if this method doesn't work, as you can see, it did not work very well, right? The second method that we learned in 1.2 is to graph these by finding the x and y intercepts. Oops, I totally spelled that wrong. I'm going to abbreviate x and y intercepts, okay? So to find the x and y intercepts, all we do is to find the y-intercept, we set x equal to 0. And I won't go through that. I think I did this exact same problem or a very similar one in the other video. And same thing, if I put in 0 for y, then we find out that x is equal to 3. Okay, so hopefully you can see from the second method, by finding the x and y intercepts, okay, you do in fact get whole numbers. So this second method would be a valid method. We could then graph that. You'd have 0, 5, and you'd have 3, 0, and then you could connect those. Okay, the third method we learned in 1.4, which is to graph the equation by using the slope and the y-intercept. So, again, you can absolutely do this, but if you think about the equation, 5x plus 3y equals 15, you can see clearly that this equation has not been put into slope-intercept form. Now we can do that, and I'm going to in a minute, but you can see that it will take a little bit of time and effort and energy. So let's go ahead and do that just for the sake of practice. If we wanted to, we could do this. We get 3y equals negative 5x plus 15. Then we would have to divide everything, all the things, by 3. And we find that y is equal to negative 5/3 x plus 5. Okay, at this point, then we would go through and realize, okay, well, this is the y-intercept right here, and we would plot that. And then when we would use the slope, we would go down 5 units, and we would go over 3 units to get that second point, and then, again, you could graph the line. So the reason I wanted to show you this example was to help you start thinking more flexibly about graphing things. Okay, all of these are valid methods. If I had chosen this first method here, when I used 1 for x and I got a fraction, what I could have done, instead of giving up and moving to a different method, is I could have kept trying different values of x until I reached a whole number. I could have also used technology if I had like Desmos or a graphing calculator to generate a table for me. Okay, so again, all of these methods are always possible. Some of them are going to be more work intensive than others. So take a minute and think about which of these 3 methods you think was the fastest and easiest way to graph this particular equation. Okay, so I think, myself personally, that this was the fastest and easiest way. And I know I didn't take the time to show the work that I did to find these X and Y-intercepts. Okay, and you would have to do that. But generally speaking, substituting 0 in and then solving is probably less work than what we did for the third equation. Okay, so for this particular equation and the way it was given to us, I would argue that this one is probably takes the most amount of time. This one is okay. It's not bad, but it's not great either. And I would argue that the X and Y-intercept method is probably the fastest and easiest way. Again, depending on how the equation is given to you, if it's already been put into slope-intercept form, then this is probably a superior method. Okay? And again, if you manage to generate random points, random values of x, and you're able to get whole number values of y, then maybe the first method is superior. Okay, so you want to know all 3 methods, and then, like on a test, you can think about which one is going to get you to your answer the fastest. So think about that. Remember, there's no right or wrong way among these 3 ways of graphing equations. It's just a matter of personal choice, preference, and also thinking about which one is going to get you to the graph the fastest.